Hey, what's up, guys? This is Akshay from AS Learning, and today I'm back with another data science interview question, which is what is sigmoid activation function? So, sigmoid activation function is one of the most popular activation functions. Whenever we have any binary classification problem, we use sigmoid activation function. So, let's try to understand what exactly is sigmoid, why people use it, and what are the different pros and cons it offers. Okay, so the function of sigmoid is 1 upon 1 plus e to the power minus x, which can also be written as e to the power x upon e to the power x plus 1, will also equal to 1 minus s of minus of x. Okay, so the range of this function is from 0 to 1. Okay, so let's calculate the range. For calculating the range, in the first function of 1 upon 1 plus e to the power minus x, here let's try to put a minus infinity. So when you put minus infinity here, this would be e to the power infinity. 1 upon infinity would be 0. So we have the lower limit as 0, and then let's try to put x is equal to infinity. With infinity, it would be 1 upon e to the power infinity, which will be 0, and 1 plus 0 is equal to 1, so it will be 1. So this is how the range of the sigmoid is from 0 to 1. Okay, then the active range we have is from minus 5 to 5. Now what is active range? Active range is where the function is actually somewhat meaningful. After this activation, after this active range, the sigmoid function will mostly give the values 0 and 1 only, but in the range of minus 5 to 5 you will be having values somewhat different than 0 and 1, somewhat in the between the range. Okay, let's try to have a glimpse of this thing. Yeah, so this is how the sigmoid function looks. Okay, now as you can see, for the values of 0, 2, 4, the values are not actually 1 or 0. Okay, they are approaching 1 and 0. That is why we have the active range of minus 5 to 5, and in that range only we have values different from 0 to 1. Apart from that, whatever input you give to sigmoid, your value most of the times will be, not most of the time, every time it would be either 0 or 1. Okay, then it is convex before 0. Okay, so before 0 means in this section it is convex. What is convex? So in this curve, if you will see, if you try to join a line segment between any two point, that line segment will be above the curve. That is why it is convex. And after 0 it will be concave, because if you try to join a line segment between any two point, that line segment will be below the curve. That is why it is concave after 0. So sigmoid function is convex before 0, it is concave after 0, active range is from minus 5 to 5, and the range is from 0 to 1. We also saw how the range is calculated. Okay, this is how the sigmoid function looks. Okay, now if you want to code, if you want to generate that graph by code, this is how you can do it. So here I've written a lambda function of my sigmoid function, that is 1 upon 1 plus e to the power minus x. This is nothing but my this sigmoid mathematical function which we have stated here. Okay, then what I've done is I've created an array, numpy array of 100 values between our active range of minus 5 to 5, and I have passed that value to my sigmoid function x, and then I've created a plot of it. This would give you a beautiful sigmoid function. Okay, and last but not least, let's see the differentiation of sigmoid and its problem. Now here we can see the sigmoid function. The blue color line is our actual sigmoid function, and this a red color dotted line is the derivation of that sigmoid. Now what is the problem with this derivation? If you can see, the derivation of this sigmoid function is having the range from 0 to 0.25. Now what happens is, in back propagation, whenever you want to update your weights, we do we do partial derivation of our activation functions with respect to our weights. Now, if the derivation of the sigmoid is minus 0.25, and if we continuously use sigmoid into layers, the value or the input will get decrease, and ultimately the gradient would get vanished out. So the problem of vanishing gradient comes from this fundamental problem of derivation of sigmoid being in the range of 0 to 0.25. Okay, so this is what we had with sigmoid. Let's have a brief overview of what we saw. We saw the formula of sigmoid, 1 upon 1 plus e to the power minus x. This function is also called as logit function or logistic regression, or function used in logistic regression. Okay, we saw its range from 0 to 1, how it's calculated. We saw the active range. We saw how it is convex and concave before and after 0. We saw the graph of it. We saw how we can generate a sigmoid function with the help of matplotlib and Python. And finally, we saw what are the flaws with sigmoid. Okay, so that's it with this, guys. If you like this video, give it a thumbs up. Do check other AI videos also. Share this video with all your friends and ML enthusiasts if you like it, and stay tuned to AS Learning for more such amazing tech stuff. Take care. Peace out.